Yeah, welcome guys. Today what we are going to be doing is called differentiation of a trigonometrical function. So this morning I'll be showing you how to differentiate a trigonometrical function. Now let's say you have y equal to sine s. So if I'm going to differentiate this, I'm going to say my u equal to what? Equal to anything here, which is what? S. So I will say the u over the s equal to, I will differentiate s. I'm going to get what? S raised to the power 1 minus 1, which is s raised to the power 0 equal to what? 1. So from here, I will now say my y equal to sine, our s is what? U. I will now say the y over the u, which is equal to what? Cos u. I hope you are getting that. So from here, I will now say the y over the s equal to the u, the y over the u multiplied by the u over the s. So from here, I'm going to say the y over the s will now be, our dy over the u is cos u multiplied by our du over the s, which is what? 1. So from here, the y over the s equal to cos, our u is s. Yes, so that's the final answer. So this is what we call differentiation of a trigonometrical function. Now, let's say you are given a question that says cos s. So from here, if I'm going to differentiate this, I will say the y over the s equal to what? Minus sine s. That's going to give me my final answer. But how do you get minus sine s? So I get my minus sine s by saying u equal to s. So therefore, the u over the s equal to 1. So from here, I'm going to say my y equal to cos u. So the y over the u equal to cos. So if I differentiate cos u, I'm going to get minus sine u. So by using my formula, the y over the s equal to the y over the u times the u over the s. So from here, I'm going to say the y over the s equal to, so the y over the u will be minus sine u multiplied by 1, which is what? The u over the s. So the y over the s equal to minus sine, our u equal to s. So this one is going to be the final answer. I hope that is clear. So if I'm differentiating y equal to cos s, the answer will be what? Minus sine s. But if I'm differentiating y equal to sine s, the answer is going to be what? Cos s. I hope that is clear. So let's take this question. Let's say we have y equal to cos into 5s minus 4. Let's say we have this question now, for instance. Now, to do this question, you will make this one your u. So my u equal to 5s minus 4. That's the first thing you have to do here. So therefore, I can now later say my u prime, which is the differential value for u in respect to s, will now be equal to, if I differentiate 5s, I'm going to have 5s raised to power what? 0, which is what? 1 minus 1 here. So from here, minus 0. I'm going to get u prime equal to what? 5. Now from here, I'm going to say my y equal to cos 5s minus 4 is equal to what? U. So I will now say the y over the u equal to, so if I differentiate y in respect to u, if I differentiate cos u, I'm going to get minus sine u. So from here, I can now say the y over the s equal to the y over the u multiply by the u over the s. So from here, the y over the s will now be equal to, so the y over the u is what? Minus sine u multiplied by the u over the s, which is what? 5. Are we getting that? So from here now, I can now say by the y over the s equal to minus sine, so u here equal to what? 5s minus 4 multiplied by what? 5. So from here, I will now say my final answer is going to be equal to 5 minus 5. I will multiply 5 by minus, then what? Sine into 5s minus 4. So this is going to be the final answer. I hope that is clear. So again, let's say we have y equal to tan into 5s minus 3. Now let's say you are given a question like this. There is actually a very easy way to solve this. You just say, now this is what? 5s minus u. What am I going to do? I will differentiate this. If I differentiate this, I'm going to have what? I'm going to have 5. So if I differentiate this, what am I going to have? I will have sec square s, which means division of tan will give you what? Sec square. Then into, write everything here again, 5s minus 3. So this is the final answer. So this is the short method for this. Why? Because if I'm going to use short method, I will differentiate this one first. After differentiating 5s minus 3, I will get 5. Then I will differentiate this again, which is what? If I differentiate tan, it will give me sec square. Then I will write the value for this place here. So this is the very short method for this. But looking at the long method now, using log method, we are still going to get the same answer. We are still going to have u equal to anything here, 5s minus 3. So from here, my u prime equal to what? 5. So I'm going to say y equal to tan into what? U. Why? Because my u is equal to 5s minus 3. So from here, I'm going to have, so y, the y over the u will now be, so the dimension of tan u is what? Sec square u. If I differentiate tan u, I will have sec square u. So from here, I'm going to say my dy over ds equal to dy over du times du over ds. So from here, it's going to be dy over ds equal to, my dy over du is what? Sec square u multiplied by my u prime, which is what? Do you know that the u over ds is still the same thing as u prime? Yes. So my u prime is going to give me what? 5. So from here, I will say which is equal to 5 sec square. So my u equal to what? 5s minus 3 into 5s minus 3, close the bracket. Can you see that it still gives us the answer while using log method? If you use the short method, you're still going to get the answer. Using the short method, differentiate your bracket. You will get 5, then you write it 5, then differentiate this, anything that is here. Differentiate tan, you will have sec square. Then write the value for this outside, 5s minus 3. Can you see that it's still the same thing? So either use the short method or the long method, you are still going to get the same answer. I believe that's clear.